One of the things that we can do with trig identities is we can simplify expressions. And we're going to exercise our reciprocal identities in this case to see if we can simplify this thing. The strategy is to take any functions that aren't in terms of sine and cosine and rewrite them in terms of sine and cosine to see if stuff will simplify. So for example, the tangent function can be rewritten using the reciprocal identity as the sine of x over the cosine of x. And then that's multiplied by sine of x, of course. So I just turned this tangent into sine of x over cosine of x. And then this secant will turn into 1 over cosine of x. Eventually. So this is 1 over cosine of x. And then we're multiplied by cosine squared of x. And let's see if there's anything we can do here. Well, we're going to, on this side, multiply the two sine x's together. And so we'll have sine squared of x over cosine x. And on this side, we will have just cosine x. And then what I'm going to do is I'm going to factor this thing. So bear with me here. I'm going to pull out a 1 over cosine x. And when I do that, I end up with a 1 over cosine x here. I have a 1 over cosine of x in this expression, so I'm going to factor that out. And that leaves me with sine squared of x. I do not have a 1 over cosine of x in this expression. However, if we backtrack to here, and I just stick this thing on top, I have a cosine squared x over cosine x, and that leaves me with a cosine squared x. And then this is our Pythagorean identity, so this is just a 1, and this ends up being 1 over cosine of x, which is secant of x. So the entire expression simplifies to secant of x. We used some reciprocal identities up here, and we used our Pythagorean identity right here. And the simplified form is just secant of x. So what we're saying is this expression up here, tangent of x times sine of x plus secant of x times cosine squared of x, is actually just equal to secant of x. Okay. Hopefully this helped. Keep working at these. It takes practice, and if you need me, you know where to find me. Take care.